So, ladies and gentlemen, let me introduce the panel. We have Andrew Burgess, who is an advisor to C-level executives sitting there at the end. Then here I have Jonathan.
The other thing I wanted to talk about was where these technologies going next. And we just kind of started to cover this a little bit in terms of where RPA is. And I think there's very different answers for where RPA will be in the future and where AI will be in the future. AI will inevitably become commoditized. My background is actually as an outsourcing advisor. And I haven't done that for 5 years now, but when I started doing it 20 years ago, we had outsourcing consultants and we all did outsourcing projects. And eventually outsourcing just became business as usual. It just became part of the normal transformation efforts that are going on in a business. And at the moment we have RPA consultants and we have RPA projects. But again, in a few years' time, these are just going to be part of the IT transformation project or the business transformation, and it's just going to be another tool that companies can use to help run their businesses, make them more efficient. And if you take that even further, I always like to the little thought experiment of, say you're the UI designer, user interface designer for a big application, maybe SAP or Oracle. So you spend all your day building nice user interfaces for your software. And at some point, you get this moment, you think, actually, I've got more robots using my software than I do people. Why am I bothering making it all fancy and user-friendly? Why don't I just have a table of data on here that the robots can access? And why do I even need to display it at all? And then you get to the point, well, then you're sort of on the road to the APIs. And as soon as I think APIs become as easy to implement as RPA is at the moment, then RPA would just become irrelevant, and these new types of APIs will become the way that systems are talking to each other, which at the moment is humans, and RPA will just become these direct interfaces. So RPA, I think, as a shelf life of maybe 5 or 10 years from now. AI is very different. As we said, it's a range of different technologies. It's continually developing. I think right at the moment, there's this perfect storm. We talked a little bit about this earlier on. We've got far more data than we've ever had before. We're creating more data, and AI feeds off data. So the more data we have, the more value we can get out of the systems. And once we've got that data, we need to store it somewhere. Data storage has gone dramatically cheaper over the last 10 years, and will get cheaper and cheaper. It's gone from buying a hard drive, a 5 megabyte hard drive for tens of thousands of dollars to pennies now. So that's taken away one of the big limitations, and obviously cloud is part of that story as well. The third thing is processing power. So computers are much more powerful than they ever used to be, and that's really important for AI because you need to run these models, and particularly the more complex models used to take weeks to run, but now can be done overnight or within hours or sometimes just minutes, depending on the complexity of the model. And that's really important because a lot of AI development is around iteration. So you try one thing, that hasn't quite worked, so you tweak something, maybe one of the features, and run it again. And if that takes days or weeks to do, you're limited in what you can achieve. But faster computers means that we can do that much more efficiently, get better results. And the last thing is everything's connected together. So everyone, the internet is kind of fundamental to this, but everyone can learn from everybody else. And particularly, again, going back to data, there's so many more publicly available data sets for AI to learn from. So you can access data sets like MNIST, which is handwritten numbers. There's facial recognition databases. All of this is used to train AI. And without that, the models aren't going to be good enough. So I think this perfect storm is really exciting now, and that's what's really driving AI. But you have to remember, all this is just narrow intelligence, as Sarah started to say in her talk, artificial narrow intelligence. So AI is very good at doing one thing very well, sometimes as good as a human or better than a human, but it can only do one thing very well. And to create a really good application, you might have to have a number of different AI processes that you kind of bring together to create an overall. But the intelligence, the cognition here, where we start to think about artificial general intelligence, isn't here yet. And it depends on your point of view. Some people think it's decades, which Rich and I were talking earlier on. I probably think it's further on, if it's ever going to happen at all. But just to give you kind of one final point on this, and to show you where AI is, some of you have heard of AlphaGo Zero, which is gaming AI that DeepMind created, which beat the best player in the world at Go. And Go's a very complex game. It's a Chinese game. It's on a 19 by 19 board. There's more moves on a Go board than there are atoms in the universe. So to give you an idea of the complexity of that, and people didn't think that AI could solve this problem for decades, but actually DeepMind did that. When they first trained it for AlphaGo, the first AlphaGo, they trained it on lots of games of humans playing humans, which is great. And it learned very quickly from that. I think it's 30,000 different games it trained on. And then it started playing itself and got very good very quickly and beat the best player in the world. Then they created AlphaGo Zero. And the difference between AlphaGo and AlphaGo Zero is that AlphaGo Zero didn't use humans as its training base. All they did, they got one version of AlphaGo Zero and one very slightly different version and started to play itself. And at the beginning, it was crap. But very quickly, it learns how to play and it develops moves, etc. And again, it beats the best player in the world at Go. The really interesting thing is, though, professional Go players were looking at how AlphaGo Zero was playing, and they noticed that it was coming up with moves that people hadn't recognized before, hadn't played before. So in effect, it was being creative. So I think this is the first idea of AI becoming creative, coming up with something that the human hadn't come up with before, because it wasn't encumbered by being trained by a human. It had the freedom to come up with solutions by itself. So I think for me, this is where the really exciting stuff for AI comes in, where we actually might come up with things that are really helpful that we haven't even thought about before. But obviously there's a downside of that where it could be very dangerous as well. And that's for the kind of the risky bit and the exciting bit about AI. That's it.
Thank you, Andrew.
Thank you.
Thank you very much. Thank you very much. A super discussion. Love to continue, but we've run out of time. I'd like to say thank you to the panel. Please put your hands together for them. Thank you. Thank you very much.